Yeah. So in the last session, I actually explained you about the data set. The data set which we are going to make use of to create the model, which is based on linear regression. Right? So we want to create a prediction model, right? We want to create prediction model with the help of linear regression algorithm. And if you see in your group, I have even shared one video where I explained the theory part of linear regression, but with one numerical, which we already discussed in our previous sessions itself. But by chance, if someone has missed it, you can go through that particular video which I have shared today itself. Okay. So let's continue with the implementation. Let me go and let me try to open Jupyter, and let me try to explain you how we gonna implement the linear regression model. So this particular part I'm not going to discuss because it is not mentioned in your syllabus, the mathematics and all those things which are in much detail actually. So I will straightforward go to problem statement, right? Because if I go and if I try to explain you all these things, it will take near about 5 to 6 sessions to finish this thing only. Okay, that's why whatever is mentioned in your syllabus, I will go along with those points only. Okay, so yes, this is what we were trying to discuss in the last session. So I hope everyone is able to remember what was the problem statement, which I had actually explained you in the last session. So if you remember, when I have shown you the data set, which was about admissions for MS, right? So if you remember, there were features like serial number was there, right? Then GRE score was there. Then TOEFL score was there. Then there was statement of purpose. Then university rating, and I think research done or not. This was, and CGPA is also one feature which was there, right? So these are going to be your input columns, right? And I told you that we gonna remove the serial number because serial number is not going to contribute to the input, output. So we are going to represent all these features with X, and the output column was chance of admission of that student in foreign university. So this is going to be your this one is going to be your y. That is, it is going to be your output. So we want to create such a model. Given that if someone comes and if someone says that out of 340 marks in GRE, he got 320 marks. Out of 120 in TOEFL, he got 180. Out of 5 for SOP, he got 4. Out of 5 in for university rating, he got 3. Research he has done. So yes or no, right? So 1 means yes and 0 means no. And CGPA was out of 10. Suppose someone has got 8. Now your model should be able to find out the chance of the prediction of admission of that particular student, whether it is 80%, 90%, 95%, whatever it is. So we want to create that kind of a model, right? This is what I have actually explained you in the last session. Now to continue with the implementation, yesterday I told you why are we using all these libraries. So pandas package, numpy package, standard scalar, I already told you. Now talking about this one, scikit-learn, I already told you that this is an inbuilt package which is there in Python, and inside that there are a lot of methods. So from sklearn.preprocessing, we are actually importing standard scalar. I hope you remember why. Yesterday I actually explained you why we make use of standard scalar, right? This is just to bring all the values to the same scale, so that not a single column will be having higher weightage, not a single feature will be having higher weightage as compared to other features or other inputs. Otherwise, if that is the case, then your model might be overfitted model. It will become overfitted model, and that's what we do not want. And that's why we make use of standard scalar. How are we going to make use of that here? That is actually shown in the code itself. Okay. Now from scalar.linear underscore model, do not worry about all these things. Reach, lasso, risk consolidation, lasso consolidation, elastic rate. This is not there in your syllabus. That's why I did not discuss all these things, right? But yeah, again, they are also very, very important. But as per your syllabus, they did not mention all these things. That's why what I will do is just try to concentrate on this one. From scalar.linear underscore model, this is linear regression. So whatever the logic which we have seen till now for linear regression algorithm, those people who are present when I explained you about linear regression, so whatever that algorithm it was doing, right? if you remember, I told you that it makes use of the equation of straight line, that's y is equal to mx plus c, where m is the slope and c is the y-intercept, right? So if you remember the example, right, Bahubali part 1, Bahubali part 2, and then people have given some ratings. So your model is going to predict what will be the rating for Bahubali part 2 if someone has given the rating at 3.5 for Bahubali part 1. So if you remember that particular example, I explained all those things theoretically. So each and everything whatever I have discussed, that will be done by this particular method. So even that's why I told you, even if you are not aware about any algorithm, for example here, if you are not aware about linear regression algorithm, but still you will be able to create the model with the help of Python. That's how Python is powerful, because see, it has got direct method for linear regression algorithm. But remember how to import this method. So you are going to get that particular method inside scikit-learn package. See, from sklearn.linear underscore model, from this one we are going to import linear regression. So this is the important thing. This is the algorithm. This is the method. This is the technology, or this is the technique which we are going to make use of for implementing linear regression or for creating the model. Once that is done, if you remember, I also told you that we are going to divide our data into training and testing. So this is the method which we are going to need to divide our data into training and testing. From where we are going to import it? From sklearn dot model underscore selection. We gonna import train test split. So train test split is actually a method which is going to help us to divide our data into training and testing. So whatever the way we want, I told you generally it is 70-30%. It can be 80-20 also. So how to do that? That is actually shown in the code, right? In the latter part of the code that we will talk about. Now import stats models.api. Now why are we going to import stats model? See, once we are going to create the model, once we create the model, we need to check how our model has actually performed. So we going to need some statistics. So this is the package which is going to help us to show those statistics. If you people are aware about something called as p-value, which is not mentioned in your syllabus, so p-value kind of a thing we are going to get with the help of stats model. Do not worry about this one. If you are not aware about p-value, don't worry. It is not there in the syllabus. But still, as a kind of information, I can tell you that p-value is something like probability value, right? So this is one statistic we generally make use of to know how actually your model has performed. So yes, to know those kind of statistics, stats model is actually a package which we make use of. Then matplotlib.py you might be knowing about it. This is for plotting, because what we are going to do is before passing the data to any algorithm, we are going to check whether our data is in normalized form or not, right? And we are going to plot the graphs. We are going to see the relationships between independent columns and dependent columns, as well as we are going to check is there any relationship between independent column and another independent column, that we gonna find out with the help of all the plots. And Seaborn is also a package which can help us to plot different figures or plots or graphs, right? So these are all the imports. These are all the necessary imports which you gonna need for creating the linear regression model. Now moving forward, after this, what I have done is I have written some definition. Define adj underscore r square. See, in the basics of Python, we have seen, if you people remember, we've seen that how we actually seen how to write down a function, right? So this is just a function. This is a user-defined function I am trying to write down. Now, what is this? This is one statistics. Later on, when we are going to complete this model development, I am going to check how my model has actually performed. So, how to check whether linear regression model has performed good or bad? So, to check that, you have some statistics. One of the statistics is R square statistics. Okay. So, and another statistics is adjusted R square statistics. Now, how to find out R square statistics? For that we have direct method in Python. That's why we did not return any function. We did not write any function for that. But there are some limitations to R square statistics. What is that limitation? The limitation of R square statistics is that, for example, here how many number of input features we have? 1, 2, 3, 4, 5, 6, 7 input features are there, right? But if I go and if I try to add some 2-3 more features which are not going to contribute anything to the output, but still R square value is going to increase. Okay, so that's a limitation. That's a limitation. Even though I am trying to add such a data which is not going to contribute to the output, but still R square value may increase. And that's why we also try to go with something called as adjusted R square statistics. Right. So how to find out the adjusted R square statistics? The formula is, see, whatever the function I have written actually, that is based on simple formula. Do not worry about all these things. Generally, people see this and they think that okay, it's really very hard. It is actually not. We have used very simple things here. Let me tell you. See, the formula of adjusted R square is something like 1 minus 1 minus R square. What is this R square? This R square is actually R square statistics, which you can find out directly with the help of Python method. That is actually shown in the latter part of the algorithm. Okay, so 1 minus R square, okay, into n minus 1 divided by n minus p minus 1. Okay, now where this n is number of records, where this n is number of records, where this R is R square statistics. Okay, and where this p is nothing but number of attributes. These number of attributes, right? So what we have done is, with the help of this particular formula, we have just written this particular function. That's it. What is this value? This value is actually, you can find out this particular value with the help of Python method, right? And if I want to tell you about the theory part behind all these things, behind this R square statistics and adjusted R square statistics, it is actually given in my notes. Right. Yesterday also I told you that I did not discuss that because it is not mentioned in your syllabus. Because if I go and if I try to talk about all those things, it will take 4 to 5 sessions at least, right? So that's why we did not discuss that. See, if I want to tell you what is an adjusted R square statistics and R square statistics is actually mentioned here. It with handwritten notes. See, so maybe once I upload the video and then I'll be sharing this IPv and DeFi. Then if you have time, if you are interested, then definitely you can go through this one. See, what is R square statistics and what is adjusted R square statistics is actually mentioned here. Okay, but yeah, for implementation, even if you are not aware about it right now, do not worry. But those people who are interested, those people who want to go further and try to learn about all this, definitely you can go through all these notes once I share. Okay, so in this notes actually I have explained each and everything, starting from the flow, how to create the model, and these methods are going to remain same for all the algorithms. It may be any algorithm, whether it's a classification problem or a regression problem, right? That is prediction problem. All the steps are going to remain same. So I actually explain all these things in detail, and from where all these things are actually taken, all the references are also given, right? So it's more than sufficient, but yeah, as actually we have some limitations here, so I'm not going to go to that one, right? So how to make use of a derivative, what is gradient descent, how to minimize the error, all the things, mathematics behind that, theory behind that, each and everything is actually explained in detail, right? So it should not happen that I did not discuss anything and I am directly going to talk about the terms like R square statistics and adjusted R square statistics, right? But yeah, as it is not there in your syllabus, that's why we will just limit ourselves to syllabus only, right? But don't worry, whatever is mentioned in your syllabus, each and everything will be covered. So as I told you, once you get all these things, you can later on go to these notes, right? So why I have shown you all those things? Because of this particular function. So this is a user-defined function which we have written, and this function is going to help us to calculate adjusted R square statistics. The formula of that I have actually shown you in the notes, right? Yes, Manas, I will be sharing the link for these notes on my YouTube channel. Once I upload the video for the today's session, below the video, as usual, you will be able to find out the link for this particular notebook, right? I hope it's clear. Moving forward. Now the time is to fetch the data. Yesterday I have shown you this particular file, admission underscore prediction.csv. It's a CSV file, right? How to fetch the CSV file? You know that we already imported pandas package. So pd dot read underscore csv is the method, and admission underscore prediction.csv is the name of the file, right? If I go and if I try to show you that particular file, I think it is here. Okay, let me show you that particular file in my case. See, this is the directory where I have actually stored everything. whatever the nodes, see how to create the nodes in Jupyter Notebook and all those things. Once you get all these files, you will be able to understand that. All the handwritten notes, all the graphs, all the figures, mathematics, everything you can actually incorporate with the help of Jupyter Notebook. See, this is the file which I was talking about yesterday, admission underscore prediction.csv. It's a CSV file, so I am just trying to import that file as a data frame with the help of Python, so that I can go and I can actually do all the operations on that file. Right? See, all these columns they actually yesterday only discussed. Right now, once we get that, yes, your answer. I will be sharing that particular admission.csv file. I will be sharing that. If you want, no problem. Okay. So people are asking for admission.csv file. I will, if you want that, see what I will do is those people who want this particular file, I will send this file in the chat box. You just check your chat box. I will upload this particular file in the chat box. So guys, you just check in the chat box. Just give me a minute. I'll be sharing this particular file with you people. Okay, just a minute. So it's a CSV file actually, as I told you. Just give me 2-3 minutes. I'm sharing the CSV file. If you want to have a look in that file, definitely you can actually go and see what type of columns are there. I'm just sharing that. So the name of the file is admission underscore prediction.csv. Okay. Yes, people, just check whether you are able to see in the chat box whether you are able to see CSV file or not. Just let me know, 1 or 2 people. Just let me know whether you are receiving it or not. Okay. Yeah, thank you. So I hope you people have received that. So you can open and you can check all the columns. Okay. So that is the file which I am going to import. How am I going to import? So see, pandas we have already seen. Pandas.in underscore CSV. Why am I not giving the complete path? Because I am already in the same directory where this file resides. That's why no need to give the complete path. Okay. So once I import that particular file, I am importing that particular file in this variable, and this variable is going to become a data frame. What is data frame? That we have already discussed. Right. So what am I going to do now? Data.head. Now head command, if you remember, head command by default shows you 5 rows. Right. First 5 records. Sharon, people are saying they have received that file. Those people who have received the file, just share that file into your group. I think Shravan Kumar, you received the file, right? Just share the admission underscore prediction.csv file into the group, into your group. Shravan Kumar, are you getting my point? Just share it with everyone. Those people who are saying that they haven't received it. Yeah. Okay, Sharon, you will get it. Now, once everything is in data variable, okay, everything is data variable. Now, head command by default shows you first 5 records. Now you can see whatever we have seen in the last session, same features are there. Serial number, GRE score, total score, university rating, statement of purpose, letter of recommendation, CGPA, research done or not, and this is going to be your output, that is chance of admission. Right. So first few records we have seen. Now we want to apply what? We want to apply machine learning algorithm. Which machine learning algorithm we want to apply? We want to apply linear regression machine learning algorithm because we want to create linear model. Right. Now to apply, yesterday I told you, before applying any machine learning algorithm, the basic thing is that first you need to check whether the complete data is in numeric format or not. Second thing is your data is normalized or not. What do you mean by normalized data? That means if you go and if you try to plot distribution plot for your distribution plot should look like this. It should be a bell-shaped curve. That is, it should be symmetrically distributed. So these two things are the basic things before applying any machine learning technique or machine learning algorithm. So that is what we are actually trying to do. So before going to see whether your data is normalized or not, you need to check whether there are some missing values present in your data or not. What is missing value? That also we have already seen. So you can see I have done. Data is nothing but what? Data is a data frame where in which we have complete data set. Whatever we have seen in case of admission underscore prediction.csv file, now is actually faced in this particular variable. So to a data frame, you can apply different methods. So I am applying describe method. So data.describe, and I'm actually trying to add argument input equal to all. That is show me all the statistics. So what it is showing me now? It is showing me all the statistics for complete data. Now it is showing me count in every column. It is showing me mean of the every column, every attribute, standard deviation, minimum value. What is this 25 percentile? If people remember, we have already seen this in box and whisker plot. This is called as quartile 1. This is called as quartile 2. This is called as quartile 3. And this is maximum value, right? Or quartile minimum value means what? 0 percentile. Quartile 1 means what? 25 percentile. Quartile 2 means what? 50 percentile. Or we call it as median. Okay. And quartile 3 means what? 75 percentile. And 100 percentile means what? Maximum. Right? One and the same thing. Those people who are present when we discuss box and discuss pod, I think they will remember. Now you can check in serial number column how many number of records we have 500. But in GRE score, if you check how many number of records or observations we have 485. Now why I did so? Because I told you count method by default ignores missing values, null values, NA values. Right? That means how many NA values are there, how many missing values are there in case of GRE? 15. Because total number of records are 500. 500 minus 15 is 485. And we are able to see only 485 number of records in case of GRE column. Why? Because it means that there are 15 missing values in case of GRE score column. That means we need to take care for that. How? That we will see in the coming slides. Similarly, in case of profile score, you can check there are 490 records, but total number of records are 500. Even I have shown you yesterday in the file itself, in that CSV file also, right? That means there are 10 number of missing values here. Again 485 for university rating. That means 15 missing values are there. SOP is okay, LOR is okay, CGPA is okay, research is okay, and chance of admission is okay. That means we need to handle missing values for GRE score, for TOEFL score, and for university rating. Why? What will happen if we do not handle missing values from these columns? Still, you will be able to create the model, but that model is going to become overfitted model. Now, what do you mean by overfitted model? I told you yesterday, right? Overfitted model is the model which will give you good accuracy at the time of training. That means maybe at the time of training it will give you 95% of accuracy. But at the time of testing in real time, it might give less accuracy. It might be 75%, 70%. And that's what we do not want. And that's why we will take care for missing values in advance, right? To avoid all those problems later on. Okay, so with the help of that particular statistic, that is count, we got to know which are the features where there are missing values. After that, what is this? Mean is nothing but what? Average. So average of GRE is 316, average of profile is 107, and so on. You can check it. Right, an average research and average CGPA and all these things you can check. Standard deviation for each and every column you can check, right? Standard deviation is what? Standard deviation is nothing but how much all the other points differ from the mean value or the average value. That is called as standard deviation. Yesterday I told you, standard deviation we actually represent with sigma, mean we represent with mu, right? Minimum value I told you 0 percentile. So minimum GRE score is 290, minimum TOEFL score is 92, and so on. Minimum university rating is 1. 25 percentile. So I think we already discussed this one also. What do you mean by 25 percentile? So for example, if you consider GRE column, okay, GRE score column. Now if 25 percentile in GRE column is 308, what do you mean by that? Now try to listen carefully. What do you mean by 25 percentile of GRE score is 308? What is the meaning of this? It means that 25 percentage of the total students. How many total students are there? 500. That means 25 percentage of 500. 25 percentage of 500 students are having less than or equal to 308 marks in GRE. That means how many students? That means 125 students are having less than or equal to 308 marks out of 500. I hope it's clear to everyone, right? 125 number of students out of 500 are having less than or equal to 308 marks in GI. That is the meaning of percentile, right? Similarly, you can take it like 50 percentile is 370. That means what? That means 250 number of students out of 500 are having less than or equal to 317 marks in GI. Similarly, you can go for TOEFL and all other columns, right? I hope everyone is able to understand the meaning of percentile. And max is nothing but 100%, right? Maximum is 340. I told you maximum of TOEFL is 120, and all these things, right? So this simple method shows you all these important statistics. And what I have done is I have just written data dot describe. See, why am I not running everything in front of you? Because again, it will take time. It will take time to load everything. Again, it will take 2 to 3 minutes for each and every command to run. So we already have very short time, right? That's why it's all everything is already run, and you are able to see the output also. See, at the end, what I will be doing is I will be showing you a model what we do in real time. That also I am going to show you. Here I am going to show you all the steps how we create the model actually. But how we make use of that model in real time with front end, with back end, right? All those things I am going to show you maybe in the coming sessions, right? But to understand those, one needs to understand this, right? That's why we are trying to spend some time here. Okay, so that's why I'm not running each and everything here itself because again it will take more time. So everything is done already. You can see the output here itself, right? Once you get this file, you go and you run it as many number of times as you want. And if you have any doubts, if you are interested, you are always welcome to ask me any question, no problem, right? So that's why we actually run describe. One of the important points which we got with the help of the output of describe is that we came to know that GRE score column, TOEFL score column, and university rating column, all these features or columns, they have some missing values, and that's what we do not. That's what we do not want. Now we are going to handle that. Now, if you people remember, when I was talking about handling missing values, I told you what is that method called as in which we handle missing values. So that is called as imputation. That means we gonna do imputation. What do you mean by imputation? Imputation means replacing missing values with some other value, like mean or mode or median. Now, in which case we are going to replace missing values with mean of the column if the data is continuous data. In which case we are going to replace missing values with mode of the column. I told you yesterday. What is mode? Mode is nothing but the most repeated value. So in categorical data, we replace missing values with mode of the column. And in which case we replace missing values with the median of the column. If there are outliers present in the data, for outliers, mean is not mean cannot be used because mean is actually affected by extreme values, and in that case, we gonna make use of median. I told you right what is the limitation of mean. I already discussed that. So, but most of the times you will find out that mean is going to do our work. That's why you might have seen many people that they are saying, okay, we always replace missing values with mean only. It's not like that actually. Maybe 90% of times we might be doing like this, but there are some exceptions where we need to make use of mean, mode, and median also. Okay, so remember that one. So in imputation, what is imputation? What do you mean by imputation? Imputation is nothing but just handling the missing values. That is called as imputation, and that's what I'm going to do now. So how are we going to do that? So see, data of university rating. What is this? This is simple indexing. What it is going to show me? It is going to show me everything from the data which belongs to university rating. So data of university rating, that is this column only. Instead of this, what am I going to do now? So data of university rating dot fill NA. Fill NA is the method to fill NA values. Now, wherever there is a NA value, wherever there is a missing value, we gonna replace that missing value with mode of the university rating. Why are we going to make use of mode here? Because university rating is a categorical data. 1, 2, 3, 4, 5. Only 5 values are there. Categories are there. right? So in that case, we gonna make use of mode. Okay. So why this zero actually? Because we make use of first value, right? This is just a simple indexing, right? This is just a simple indexing. Try to understand what this first line is doing actually. This first line, what it is doing is it is just replacing missing values. Wherever there are missing values in university rating column, we are replacing those missing values with the mode of university rating column. That's it. That's what it is doing, and it's a simple pattern, basic pattern. Similarly, we are going to do it with TOEFL score. Now, TOEFL score, here it's a score, right? Continuous data. So, what are we going to do? Now, wherever there are missing values in TOEFL score column, we gonna fill those missing values. We gonna replace those missing values with mean, that is the average of the TOEFL score. And same is the case for GRE, right? So, what is this? This is called as imputation step. Okay, handling missing values, that is called as imputation. So with the help of basic Python and concept of indexing, we are just doing that. Okay, after that one, once we are done the imputation, now once again go and try to fire this command, data dot describe. Now if you remember what was the earlier output, you can check. For data dot describe, GRE was 485, count of GRE was 485, count of profile was 490, and count of university rating was 485. Now, after completing the imputation step, now you go again and you check the data not described, and now you will see that count for GRE score is 500, count for profile score is also 500, and count for university rating is also 500. That means what? That means after doing this, that means we are complete. We have actually correctly done the imputation part, and now here there are no missing values in any one of the columns, right? That means we are good to go. See, now it is given here. Now the data looks good and there are no missing values. Also, the first column is just a serial number. I already told you serial number is not going to contribute anything to the chance of admission. That is output. So we don't need that particular column. So let's drop it from the data and make it more clean. So what is this? What are we actually doing right now? We are just doing we are just doing the data cleaning part. Okay, this is called as simple cleaning, I can say, right? After that, so you can see here, you can see here, as it is mentioned that the serial number column is not going to contribute anything to the output, right? So we are going to what we can say, we are going to drop that particular column. Okay, so how to drop that particular column? Now you can check it. See here, data.drop is the method which we can make use of to drop the column, right? So data is equal to data.drop columns. Which column you want to drop? Serial number column you want to drop, right? So you can see this is a simple ready-made method. It's a by default method available for data frames in case of Python, right? That's what we are going to make use of. And now we have dropped serial number column, serial number attribute or feature from the data frame. Right? Now you can check data dot head. Now you can see there is no serial except serial number. All the other columns are there. Now what? Now let's see the dependency between the input and the output feature. See, always remember what we need is, I told you that for x is going to be input and y is going to be the output. Now, to x we are going to assign all those columns: GRE score, TOEFL score, university rating, segment of purpose, and all those things. And y is going to be chance of admission. Right? Now, this x is what? All the x are independent columns. Right? And this y is what? This y is dependent column. Now, we have seen that if this is your table, right? If this is your y and your x have been assigned all these columns. Now, if y is dependent on any one of these columns, that is okay. If y is dependent on this column, okay. Y is dependent on this column, okay. But one independent column depending on another independent column, that's what we do not want. Dependent column depending on independent column is okay, but independent column depending on another independent column, if it is the case, then again there will be a problem of overfitted model. Okay, so that's why what we do is we try to check the dependency or the relationship between independent features and the dependent features, right? So whatever the code which you are able to see, we have used matplotlib here, matplotlib package and seaborn package. So you can check. SMS means what? SMS is seaborn. Seaborn dot distribution plot. So dist plot is the direct method available in seaborn package. Data is nothing but what? Data is our complete data. What is column actually? So column is nothing but all the columns. Column is just a variable here. See, for loop I have written for column in data. What is there in data? In data we have complete data. So for some variable that is column in data, if plot number less than or equal to 60, that 16, that means we are going to plot 16 plots. Each column opposite every other column. So distribution plot I am going to plot. Simple way. I am going to make use of. We are making use of matplotlib and seaborn package. That's it. Okay. Later on you can go and you can check. Now the important point is that why are we doing it? So because we want to check the distribution of the data. Why we want to check the distribution of the data? Because I already told you that the basic requirement before applying any machine learning technique, before applying any machine learning algorithm is that your data should be numeric. Our data is numeric. First condition is okay. Second condition is that your data should be normally distributed. What is normal distribution? That means the distribution should be symmetrical. It should look like a bell-shaped curve. Now that's what we are actually. That's how we are actually trying to plot distribution plot. So here you can see for GRE score, distribution is somewhat symmetrical or normal, I guess, but still there is some skewness. This is also good, but still there is some skewness. This is, yeah, it's okay. You are able to see like this because it's a categorical data. That's why we are able to see like this. This is also okay, statement of purpose, but still there is some skewness. Yesterday I told you what even the skewness, right? Here LOR is also okay, but yes, there is this skewness. See, normal distribution is what? It should be symmetrically distributed, equally distributed. If I divide it into two equal parts, that is possible, right? If you are having the distribution of the data, some column, something like this is not normal distribution. This is skewness, this is positive skewness or rightly skewed data. Okay, and if the distribution is something like this is called as negatively skewed data or left skewed data. This is what we do not want. What we want is we want symmetrical distribution, and that's why we are actually trying to do it like this. So similarly, you can see the distribution of CGPA research is like this because there are only two values, 0 and 1. That's right. And chance of admission again somewhat symmetrical, but yeah, we need to take care for little skewness here. See, the data distribution looks decent enough. There doesn't seem to be any skewness. But yes, see, as I told you that there is some skewness which can be neglected, right? If you want to go and if you want to clear that, yes, that's possible. What you need to do is you need to go and you need to actually try to check for the outlier values and this remove those outlier values. Okay, so it all depends on what type of problem statement you are actually dealing with. So we are assuming that okay, we do not have that much of skewness and we are good to go. Now, next thing is what? Now the next thing is divide your data into input and output. As I told you that chance of admission is the output, right? So output we have assigned to y variable. Except chance of admission, everything is going to be assigned to x. So that's why what we have done is data dot drop columns equal to chance of admission. That means except chance of admission, everything you assign to y, everything you assign to x, and chance of admission from data is actually assigned to y. That means 2x, which columns we have assigned? We assigned GRE score, right? Profile score, statement of purpose, right? University rating, letter of recommendation, research done or not, and CGP. All these features are assigned to x, and chance of admission is assigned to y, right? So y is our output and x is our input. So earlier we plotted distribution plot, and in that we have seen the distribution of each and every column. Now again we are going to make use of Seaborn and Matplotlib here, and here this time now I am going to plot scatter plot. Why scatter plot? Now this time I am going to check the relationship between all the independent features and the dependent feature. That means I am going to see the relationship between all the input columns and the output column. That means output column is what? That means I am going to check the relationship of chance of admission column, that is output, all the other input features. So whatever the code which you are able to see, again this is a simple code with the help of matplotlib. Okay, PLT, just a alias we have used, variable we have used for matplotlib. So I am going to make use of scatter plot. If you go and if you try to see this plot, now you can check. You can check the relationship of each and every input column with the output column. You can check it. GRE score with chance of admission. TOEFL score with chance of admission. University rating with chance of admission, and so on. Now you can check GRE score and chance of admission, how they are related. So overall, if you look at, you can see as and when GRE score increase, chance of admission also increase. So this is somewhat linear, right? More or less, it is linear. Same is the case with TOEFL score, and it's a common sense, right? If obviously if TOEFL score is increasing, chance of admission is also going to increase. University rating is actually a categorical data, that's why you are able to see the graph like this, but still it is in this fashion. That is linear fashion, right? The relationship between chance of admission and GRE score is linear. Same is the case with TOEFL and same is the case with university rating. And if you go and if you try to check with others, you can see even CGPA. Obviously, if your marks increase, your chance of admission also going to increase. This is also linear, right? More or less, it's also linear. So most of the times you see that the relationship between all the input features and the output feature, all the input columns and the output column is more or less linear. So that's a hint, that's a good point for us to go with linear regression algorithm, right? That's one way to identify that, okay, I can go and I can apply linear regression algorithm in this case because I can see the relationship between the output columns and the input columns is more or less linear, right? So that's one of the most important reason why I'm going to go with linear regression in this case. But let me tell you, in real time, in practical scenarios, what happens is we never make use of only one algorithm or only one technique, only one machine learning technique. We never make use of only one machine learning technique in real time scenario. What we do is, suppose there is a problem statement from the client, okay, and in that they want to create a model where we need to create a prediction model, regression model. So I know that for prediction or regression model I can use linear regression, but there are other techniques also which can be used for creating the prediction model. Instead of depending on only one algorithm, in real time what we do is we try to make use of 6 to 7 algorithms at a time, and then we apply such techniques which help us to find out which is the best algorithm or which is the algorithm which has given you the best model for that particular data set. So that model we select finally. So always remember, okay, that's why even I told you that even in my training, what I do is I try to talk about 15 to 16 algorithms. Why I did so? Because we never know what kind of a data you are going to get, right? So always remember, it's not like we only make use of only one algorithm. No, we make use of 6 to 7 algorithms on single data set, and then whatever is the best, we choose that. How to find out which one is the best? For that, we have some techniques, like there is something called as ROC underscore AUC underscore score. Again, this is not mentioned in your syllabus. Receiver operator characteristic area under the curve, right? So this is what we use in real time to find out the best model out of 6 to 7 models. Okay? But yeah, here I am going to make it of only one model. So the point is that now we came to know that, okay, the relationship between all the independent columns and the dependent column is linear. That means I am going to go with linear regression, right? See, the relationship between independent and independent variable looks fairly linear. Thus, our linearity assumption is satisfied. That means we are good to go with linear regression. After that, what? Now is the time to make use of standard scalar. I hope you remember why we make use of standard scalar. So, standard scalar we are going to make use of because standard scalar is going to help us to bring the data to the same scale. Why we try to bring the data to the same scale? Because it should not happen that a particular column will be given more weightage, right? So what standard scalar is going to do, if you remember yesterday I told you that the example of square root, right? For each and every column, all standard scalar is going to take the square root of all the values, or maybe log of all the values. So what will happen because of that? The difference between values of all the features is going to be very, very negligible. And because of that, what will happen? Because of that, equal weightage will be given to all the features. And because of that, your model will not be overfitted model. Right? And that's how we make use of standard scalar. So what are we doing here? I am calling this particular method standard scalar, and I am creating an object of that is called a scalar. And what is this x actually? I told you x is going to be what? X is your input feature. So all the input features are assigned to x variable, right? If you remember, we already divided our data into input and output. So you can see that this x, what is x? Except chance of admission, everything is assigned to x. So what am I going to do here? I am just trying to standardize all the input features with the help of standard scalar method. So I have created an object called as scalar, and using that object scalar here dot tweak underscore transform of x. X is all the input features. So even maybe whenever you have time, you go and you run this code and you check the value of x underscore scaled data, you will be able to see different numbers. But the difference between the numbers is going to be very, very less. So we have seen that okay, GRS score is out of 340, total score is out of 120, university rating is out of 5, but all the values will be on the same scale. So that is what we will be able to see as output of this. Once that is done, we make use of something called as, so once standardization is done, we make use of something called as variance inflation factor. Again, this particular topic is not there in your syllabus, but let me tell you why we make use of this. It is called as VIF. VIF we always make use of to find out whether one independent column is dependent on another independent column or not. Right? So if the value of VIF for some column, for some feature, if it is greater than 5, that means that column is dependent on another independent column, and we need to remove that multicollinearity. See, if if dependent column is dependent on independent column, no problem. But if independent column is dependent on another independent column, there is a chance that your model will become overfitted. So how to find out that whether one independent column is dependent on another independent column? We use a method called as variance inflation factor, VIF. If the value of VIF is greater than 5 for some column, that means that there is a multicollinearity present. See, if there is a relationship between independent columns, that is called as multicollinearity. And multicollinearity should not be present in the data before applying any algorithm. And that's why we go for multicollinearity. That's why we check for multicollinearity. How to check for multicollinearity? With the help of VIF, variance inflation factor. Again, it's again a separate topic actually, but I'm just trying to introduce in short. Okay, so that's why I actually imported this particular package, this method, and I am going to apply that particular method on my data. Okay, x underscore scaled I am going to assign to variable, and I am creating an empty data frame. And for each and every feature, I am trying to find out the value of VIF, variance inflation factor. So you can check GRS score, variance inflation factor is 4.15. Total score, VIF value is 3.17. So you can check in our case, no VIF value is greater than 5. Right? That means there is no multicollinearity present in our data set. That means we are good to go. And the next step is divide your data into training and testing. Okay. Okay, people are, I think they are, okay, I think people are sending roll numbers. So yeah, no problem. I think you people are in hurry. So what I will do is, I will stop here. You send your numbers. Okay, no guys, no problem guys, no problem. I will stop here and I will continue in the next session. Okay. So in the next session, we will start from dividing our data into training and testing. So yeah, send guys. Those people who are in hurry,